This is a tutorial for calculating some probabilities using a Poisson distribution. Taking a look at our question, Niwa states that there is an average of around 8.5 damaging tornadoes that occur in New Zealand each year. Find the probability that there are less than 2 damaging tornadoes in a month. First of all, I know I'm using a Poisson distribution. And the parameter I need is lambda. Now, when I read through the question, I'm given an average of 8.5 tornadoes per year. However, the question is talking about how many tornadoes in a month. So for my lambda, I need to get the two intervals to match. I know there is an average of 8.5 tornadoes per year. So to work out the average per month, I need to divide 8.5 by 12. So that's an average of 0.70833 tornadoes per month. This is the lambda that I want to use in my calculator when I'm working out the question. Now to write our probability statement. We're wanting to find the probability that there is less than 2 tornadoes in a month. So less than 2, that means I'm looking for the probability of there being either 0 tornadoes or 1 tornado. So the probability that x is less than 2 is the same as saying the probability that x is equal to or less than 1. Now we can go over to the calculator to work this out. Here's the calculator I'm using, a Casio graphics calculator. When you turn it on and go to the main menu, we want Stat, Distribution, scrolling across till we find Poisson. So this one here, Poisson. This time we're going to choose PCD because we're working out a cumulative probability because we're wanting x to be 1 or less. Now, next to data, it should say variable. X, we have 1. Next is lambda, which in our case is 8.5 divided by 12 because we're wanting the number of tornadoes per month. So checking what it says, we have an x value of 1, so that means the calculator is going to be counting down and working out the probability of 1 or 0 tornadoes per month, and a lambda of 8.5 divided by 12, which works out to be 0.70833. Executing. And there we have our answer that we're going to write down. Writing down our answer, we have 0.8413 to 4 decimal places. Now looking at our second question, we have find the probability that there are 5 or more damaging tornadoes in a year. So again, I'm going to be using a Poisson distribution. Still have the parameter of lambda. In this case, the question is talking about the interval of a year. So that means I need my lambda to match. So I'm going to use my average of 8.5 tornadoes per year. Now for the probability statement. We're trying to find the probability that x is equal to 5 or bigger. Now I can't use 5 as x in my graphics calculator because the calculator is programmed to work out range probabilities counting down. So if I did use 5, it would be finding the probability of 5, 4, 3, 2, 1, or 0 tornadoes in a year, which is not what I'm after. So I'm going to write a reverse probability statement, minusing what I don't want from 1. So that looks like 1 minus the probability that x is less than or equal to 4. 4 is the first number of tornadoes that I'm not interested in. I'm interested in 5 or above, not interested in 4 or below. Going across to the calculator. Again, I want the stat option from the main menu. Distribution. Scrolling across to find Poisson. This one here. Still wanting PCD. I'm still working with a cumulative probability, wanting to find a range, not an individual number. Changing x to be 4. This time lambda is 8.5 because we're interested in the number of tornadoes per year. So we've got an x of 4, lambda of 8.5 tornadoes per year. So we're going to execute that. And there we have our answer that we need to use. Writing down our answer. And there we have our answer to 4 decimal places. There we have 2 examples for calculating sum probabilities using a Poisson distribution. The first example, we were able to go straight to our calculator because we were trying to find the probability that it's less than a number. And in the second example, we first needed to write a probability statement minus from 1 because we were trying to find a probability that is bigger than a number, and our calculator is not programmed to work in this direction. It's only programmed to work going down from a number.